So as I'm trying to build out this online top-down zombie-based shooter, one of the things that I started running into was like having trouble building out the tile maps. Right now, this game randomly picks various types of tiles. I call them biomes and places them throughout the map. For example, we have a farm here, which random gasoline cans will spawn. I also have a city biome, and then there's like another biome that I cannot remember at this point. But basically, it was becoming very hard and tedious to like hard code all these. And so what I did was I ended up adding a custom editor. So over here we have an actual editor which runs locally. This doesn't run on production, but it allows me to basically load up my biomes. So I have city, I have farm, I have forests, different forest variations, I have a gas station, and then the edges of the map. I don't know why this is called water. I need to refactor this. But I can come in here and I can quickly add a new biome and I can remove one, I can edit them. But this video isn't to talk about my game or this editor. This is actually to talk about a computer science algorithm called flood fill, which uses something called breadth first search, where I can basically select one of these tiles and select the fill bucket, and then I can change all the tiles that are of the exact same type. So for example, if I click on this water and I want to change them all to be trees, I can do something like that, or I can switch all the trees now to be this, and then I can switch all those to be trees again, and then I could probably switch them back and just keep doing this, right? So I'm going to try to walk you through how flood fill kind of works, how breadth first search kind of works, and I'm going to try to do this without using AI to show that I'm actually able to code without AI. So we'll see how long this video goes for. Hopefully it doesn't go for too long, but breadth first search is a very important algorithm you should probably learn if you're dealing with making games or just traversing graphs in general. All right, before we dive into code, I do want to kind of break down how flood fill kind of works. So let's just go ahead and make a grid here. I'm going to make a couple of columns and rows so we can all kind of have a good example of what flood fill and breadth first search does. So the way breadth first search kind of works is you have a queue. So over here, I'm going to say queue, and you pick a starting location. For example, we'll say like 2, 2, and you're going to push that into the queue over here. And the idea is that you pop off a location in the queue, and you have like an array to keep track of like what you've seen already. So in our case, we're going to have a set of various locations, 2, 2, and we're going to pop the 2, 2 off the queue. We're going to say that we've seen this, and then we're going to look at the adjacent cells. I'm just going to keep this, top left, bottom right to keep this simple, but you could potentially do diagonals as well. And we're going to push those other locations into the queue now. So in this case, let's just go right first, which means that we would be 2, 3. I am going to keep this to be the Y. So this is 0, 2, 3, 4, and this is 0, 1, 2, 3, 4. Okay, I should probably center those. All right. Okay, so we just pushed 2, 3, which means that we need to make sure that's in the queue. And then we're going to also push another one down here. This would be 3, 2. And then we're going to push, let's just say this one. We could say 2, 1. And then we're going to push the one on top, which again would be 1, 2. Again, the left side, this is going to be your Y direction. And then the right side, the second number is going to be your X column. So we basically pushed all those, and make sure you push them into the queue in order so we can kind of keep track of that. And then eventually we have all these in the queue. Okay, so the next step of this algorithm is you keep on popping off the queue or dequeuing off the queue. So 2, 3 is where we're going to be at right now. We're going to get rid of that. We're going to add that to the scene array. And then we're going to do that same algorithm. We're going to go ahead and just push the one on that's on the right, the one that's below, the one that's to the left, and then also the one that's above. Now, this is where the scene set comes into play. We've already seen 2, 2, right? So technically, we don't have to push this one back into the queue. But the other locations, for example, we have 2, 4. That definitely needs to get added to the queue over here. So we're going to add it. This one down here, we're going to go ahead and add this one. This is 3, 3. And then, of course, we're going to have 1, 3 get added. Okay, so 3, 3, make sure you add that in as well, and then 1, 2. Okay, so as you can tell, the queue starts filling up really quick, but the algorithm remains the same. You keep on taking off the queue, so now we're going to be at 3, 2, which would be this one, and we're going to get rid of that. We're going to add it to the scene array, 3, 2, and then we're going to do the same thing down here. We're going to go left, right, down, left, and up. You're going to keep the same orientation happening every time. So if it's right, bottom, left, up, it's going to add it in that same order every single time. But now in this case, I think actually when you push it to the queue, you should probably be adding it to the scene array. So I think I'm kind of misteaching that, but I'm too lazy to kind of remake this video. So technically I should have 3, 3 in here. I should have like 1, 2. Every time you push into the queue, make sure you update the scene array or some type of way to know that you don't need to re-push this value, okay? So we are at 3, 2, and again, we're going to say, do we need to add 3, 3? No, because we already have it. We do need to add this one, we do need to add this one, but we don't need to add the top again. Okay, so hopefully this should make sense. Eventually you will exhaust the entire grid, assuming that there is a way to move left to right. Okay, but if there's no like constraints on like traversing your graph, eventually you're going to get circles in all these different cells and the whole queue will be empty, and then you'll know that you're done because the queue is no longer able to process any cells that you haven't seen before. Now, when it comes to this type of game, there is a little constraint. When you're doing flood fill, you can't change the value of a tree if it's not the original starting type. So we're going to add like one additional thing here. We can have like a unique identifier, like an ID for the tile. So this tile could be A, this one could be A, this one could be A, this one could be A. Just assume the other ones have A's as well. But if you were to try to push in a tile that maybe has a different ID or type, for example, this could be a B type of tile, you would never push that into the queue, okay? So you basically just skip it. So eventually you're going to go ahead and traverse all these different places, but this one will never actually be added to the queue or traverse. So like the pathing has to kind of go around in this type of orientation, right? So if you have a bunch of these different things or like a group of these, it'll actually just bypass all of them. And then eventually you'll find all the things you could potentially get. Now, the reason this is useful, let's just make a new biome. I'm going to say testing, and I'll go ahead and create that. Let's just flood fill it into all this. And then I'm going to go ahead and just place in, some water tiles, right? If I wanted to change the water tiles to be something else, like for example, this grass, I don't want it to spill over and start changing the actual ground to a different tile type. So if I click on here, notice that it only ever changes all of the tiles that match the original ID that I clicked. So that is the algorithm. It's using a breadth first search. This is called flood fill, and that is what I'm using in this editor. You've probably seen it, the paint bucket tool with like MS Paint or Photoshop. All these other editing tools have this same type of thing. Now let's see if we can actually implement some type of breadth first search in code and hopefully not use AI. All right, so I have a file called other, and we're going to try to do this by hand. I'm going to have a 2D array. So I'll say A, and I'll make a couple of these. So I'll just, make it like a 4x4 grid, something like that. And then we're going to just put a bunch of other values as well. So just go ahead and do this times, and then I'm going to change some of these to be B's so that we can actually demo like the flood fill working the way we'd expect it to work. All right. So the first thing that we need to do is we're going to render this out to a screen here. So I'm going to say grid.map, and this is how you can kind of render out in React, arrays or something. And we want to kind of do like a 2D looping of this. So I'm going to do a map, and this will be the row. And then we're going to go ahead and just return a div here. And then we're going to do another map inside of here. I'll say row.map. And this will be the actual cell value, like this. And then again, we're just going to make a div. And then we should eventually, hopefully, get that to auto format. And then we're going to put the cell value right there. All right, so these are all rendering out on the left, but we want to kind of put them in rows. So like we could just do a little bit of CSS magic here. I'll say class name. I think I am using Tailwind, so I'm just going to go ahead and put this as a display of flex or something. And that should put them on the same row. And then we could probably just give some padding. I'm going to say padding of like 8 on all these cells. Okay, and then we could also give them, I don't know, a border. Here we go. So we got a grid, right? Now I want to be able to click on a cell and have it do that breadth first flood fill algorithm and fill in the value. Instead of it being B, I want to change it to something else like X. All right. So I'll just go and say like const target, and I'll say like X. And we want to implement that flood fill algorithm. So I'm going to add an on click to one of these divs. Technically, these should probably be buttons. We can actually click them, and that's semantically correct HTML. But I'm going to say on click, and then we're going to call a method. I'm going to say flood fill. And then we do want to keep track of the actual like starting point, like I mentioned in that diagram. So we should probably have the I, and that's going to be the row, and then the cell we could say J. I like using I and J. You could have used Y and X if you wanted to, but I'm going to say I, J. Now we actually need to add in a method which will be able to traverse this grid and replace the values. Now I do need to convert this to React state, or else this isn't going to properly like update. So I'm going to go ahead and say like const grid is equal to use state, and then we're going to go ahead and just bring in, we're going to pass that in as the initial thing. All right, so now we actually need to flood fill. So let's make a function called flood fill. I'm going to do it directly inside of this component so it has access to the state variable. We can kind of modify it as we're like changing stuff. And it's going to take in a start I and a start j. Okay, so we're going to pass in some parameters. Technically, those will be numbers. So let's do numbers here. And what we want to do is we want to implement that algorithm that we just talked about, where we have a queue and we have a scene array. So I'm going to say const queue is equal to, we could just make an array. We could say also scene is equal to a new set. And we could probably just do that as well. Okay, so the first thing we're going to do is we want to push in that start I and start j into the queue. So I'm going to say I is equal to start I, and then j is equal to start j. Okay, so we can save that. And then what is the algorithm again? We want to do, like we want to keep on looping while, I guess I could say while queue.length has something in it. We're going to say the current position is equal to queue.dequeue. Actually, I don't remember how to do it. Is it like unshift or is it shift? Let me make sure I'm getting this right. Removes the first element. Yeah, so we're going to remove the first element from this queue. That means our current position is going to have wherever we clicked on the board. So if we clicked on the middle here, this is 2, 2. Then we're going to start here. We're going to traverse it and start filling in all the values with that target X, okay? Now, like I mentioned, we have to push in, we have to like loop over the different directions. So I'm going to say const directions is equal to, and I can just go ahead and make a list of like I'll do -1, j of 0. So this is going to go up, and then we're going to do +1. That's going to go down. In fact, I want to go up and then to the right. So that's going to be j of 1, I of 0. And we're going to go down without going x any direction. And then we're going to go to the left here. Okay, so that should be direction up, right, down, and to the left, right? So we're going to loop over these. We're going to say for let direction of directions. And then we want to make sure that we're not going to go out of bounds and also that we're not going to see something that we haven't seen before. So if, and this is kind of the interesting part, we're going to add the current position. In fact, I'm going to say const new I is equal to current position I plus direction.I. And then we're going to say new j, again, is current position j of those things. Let me make sure I fix that. All right, what is current position complaining about? Is potentially undefined. So if we have shifted off, in fact, we shouldn't be able to shift if there's nothing in it, right? So this should be greater than equal to 0. Or sorry, greater than 0. I'm going to put an exclamation mark there because we know we shifted off something that should exist, okay? Okay, so we have the new direction that we're trying to go. And again, we want to make sure that we're not going out of bounds. So if the new I is less than 0, or the new I is greater than the total size of the grid, so like we could do grid.length, then we know we should probably like skip that direction, right? So I'm going to say continue, like just skip it. Also, if we go out of bounds in the j direction, so if we are less than 0 in the j, or if we are greater than, I'll say grid of just 0, to know how many columns are in this grid, we want to continue. We don't want to like go in that direction. So these are like edge cases. Make sure you're not going outside of the grid or else you're going to get an error that's going to crash your app, right? Okay, so now eventually we know that we add a valid location. Now we want to check, have we seen it before? So if we've seen this thing, which we can actually just say like, we'll do a string interpolation. We'll do a little hack in JavaScript. We'll say new I, new j. If we have seen this thing, in fact, this is a set, so I think we can say has. If this thing has this already, which, what am I doing wrong? I need a money sign, okay. Then we can also continue as well, okay. There we go. So finally, we're at a spot that we haven't seen and it's not out of bounds. So what do? We're going to go ahead and just push to the very end of the queue. We're going to push in an I, which will be a new I, and a j, which will be a new j, okay. So again, that's the algorithm I kind of talked about. We are pushing into the queue, but then also we want to add to the scene array. So let's make sure we go here and just say scene. And I think you can say add. Yeah, we'll just add that in. Just to know that we've seen it before. And then also, we should probably actually initialize this scene with scene add of start I and start j. We want to make sure we don't go to the same spot again. Okay, so eventually, we should exhaust the entire graph, and this will loop over every single cell inside of our 2D grid. Now, the last thing we want to do is we only want to flood fill the value that we originally clicked. So if we clicked on start I and start J, I could probably say start initial value, and then we could say grid of start I and then start J to get what that value is. So this will be the B or the A, right? We need to know what thing we're trying to fill in. So we're going to grab that, and then we're going to have yet another if statement. So if the current thing we're trying to go to, I'm going to say const value under eyes. I don't know. I can't think of a good name for that. I'm going to do the same thing. We're going to say get the grid, and then we're going to go here. But then we need to say new I and new J. Okay, so we're going to get the, I'll say next value. And so if the next value is not equal to the, what do we call it? We called it the initial value. Then again, we don't want to like replace this. We just say continue. We don't want to add it to the queue because we don't want to replace it, right? Okay, so now I think this should all be pretty good. Now, the very last thing we should do is when we pop something off the queue, the thing we do need to do, though, is we need to replace the grid. So I could say grid, technically this is state, so I have to say set grid. So now it's going to be a little bit confusing if you don't know React, but basically every time you take something off the queue, you want to replace it. So I'll say set grid, and then I'm going to say current grid. I'm going to give it a callback function because we're going to be doing a lot of these inside of this while loop. We want to basically take the current value. I might just do this. So spread out the whole grid, but we actually want to change out. I'm going to do this. New grid of current position I, and then current position of J. Let me make sure I grab this. Equals, and I'll just say target. We want to set them to X's, right? And then finally, we can return the new grid. When it comes to updating state, it's kind of annoying. Like, I'd probably rather have Immer or something that allows me to just like update these things in place, because sometimes you actually have to like, make sure you're not referencing in a 2D grid. You might have to like map this, and then I might actually have to do something annoying like this, like do an array that's spreading that, because otherwise React doesn't really know how to like do the reconciliation process. But let's just try this out. I'm going to go ahead and I think this might actually work okay. I think we could try this. This might crash our app completely. But again, this is the first time coding. I promise I didn't like memorize how to do this. We do need to add a key to these things. So we probably need to go down here, and I need to say this will be a key of I. And then this one, I think I'm going to say key of I and then J. Definitely want to add keys to your React arrays. Or sorry, your React components. Okay, let's just try this out. Okay, so notice if I click on the A's here, they all become X's. The flood fill basically changed them all to be X's. There is a little issue. Cannot read property of undefined reading 0, flood fill of line 60. So let's try to figure this out. I think this actually needs to be greater than or equal to. So a simple off by 1 error, I think I can fix it just like that. So let's click on this, click on A, and notice that it flood fills all the A's to be X's. Click on this, it flood fills them all to be X's, flood fill that all works. And I could eventually flood fill everything. And yeah, that's basically the algorithm. So hopefully you guys paid attention to how that kind of works. Now, one thing I'd probably want to do is I could make this look a little bit nicer so that as it's flood filling, it could be delayed a little bit. I'm not sure what the best approach to doing that. I think I could probably add some type of set timeout here. Set timeout. I don't know if this is going to achieve what I want, but like, let's just try it out. I'm going to go ahead and just put a set timeout so that it does take a little bit of time to actually make these things happen. So I'm going to do like 100 milliseconds, but we do want to make sure that we add like, what was the previous delay? I'll just say like let delay is equal to 0. And then every time we do this, I'll just do delay plus plus, and then I'll times this by delay. Very hacky way to do it, but basically every time we're trying to... Actually, I might put the delay outside of that. Okay, let's try this out. So now it should slowly, if I change this actually to 800, let's do 800. If I click on this, it should slowly start changing them. And you can see the algorithm kind of work. It kind of slowly traverses the grid like I showed you in the diagramming tool. And then eventually the queue gets empty and everything's done. So we could try it again down here. I'll click on the B. You'll see that it traverses all the way up. and then it flood fills over there. Let me turn cursor tab on, and I'm actually going to say, make this grid look much better so I can demo it on a YouTube video. Okay, I'm going to go ahead and just like let it style my grid, and we can kind of see if that'll make the flood fill a little bit better. Okay, ton of code. Don't know what's going to happen here, but now we have a nice flood fill demo. Let's click on the A's over here, and you can see it's going to slowly convert them to be X's. I'm going to do one more change. I'm going to say, when the value is X, make the BG of the cell green. Okay, let's click it. Okay, that didn't really do what I was wanting to. It put check marks in it, but you can kind of see the algorithm kind of working, where actually if we change the grid itself to be, I don't know, a bunch of B's, we can kind of see how it's going to traverse it with the flood fill pattern. So I'm just going to go ahead and change all those to B's. I don't know why I just did that all by hand. I could have just done a quick find and replace. Let's refresh this, and I'm going to click it. And you'll see it goes up, right, down, bottom, and then it goes to this one, and then it should go to this one, and it goes to this one. And it's kind of like traversing with a breadth first search to convert everything to check marks. Anyway, hope you guys enjoyed that little overview of two different algorithms. We have breadth first search and we have flood fill, which I think is very important when you're building out a game. And I just wanted to kind of stress my knowledge coding stuff without AI, because I've been using AI for so long now that I don't feel like I remember how to code, but I do know how to code after all. So that was a good little exercise for myself. If you guys enjoy this type of overview or type of practice, and you're a beginner, I will say I have a beginner React challenges where I have like 20 plus little examples of building out various things, like a memory game. We have a histogram assignment game where I do the same type of breakdown. I'll break it down with a diagram, and then I will implement it in code. I think I do use AI when I build this out, so keep that in mind. But if you guys are interested, I think it's like 20 bucks. Go to beginnerreactchallenges.webdevcoding.com to check it out. Other than that, I mean, have a good day and happy coding.